All right, medians and altitudes of triangles. So we want to be able to identify them and use them in these problems. So the median is a segment in a triangle with the endpoints being the vertex and the midpoint of the opposite side. So if I had a triangle like this, say here's the midpoint and here's that line. So that would be a median on there. The centroid is the point of concurrency of the medians of the triangle. So all three medians and where they intersect each other. If I try to draw this freehand here, let's see how I do. So these all intersect at that point in the middle. So that is the centroid on there. Centroid theorem says that the centroid splits each segment into a 1/3, 2/3 ratio. So on here, this would be 2/3 of the way across, and this would be another third on there. An altitude is a segment from a vertex to the line perpendicular to the opposite side. So if I add this, it's always going to come down at a 90-degree angle no matter where it is in that triangle. So even if it lands like right on the inside, it could even land on the outside of the triangle if I drew an obtuse one here. So this would be the altitude right there. It actually lands outside of the triangle because it has to be perpendicular there. And the orthocenter is the point where all the altitudes run into each other, or the point of concurrency. So in triangle XYZ, P is the centroid, and YV is 12. Find YP and PV. So YV, this whole length, is 12 on here. So YP is 2/3, because this is the 2/3 section, the one that's coming off of the angle is 2/3 of the whole thing. So YP is 2/3 of YV. Now YV we know, that's 12. So 2/3 of 12 is, I think about it as what's a third of 12, or 12 divided by 3, that's 4. And 2 of those would be 8. So YP is 8. And then if we go all the way across, you can just use the segment addition postulate. This piece plus this piece has to equal the whole thing. So 8 plus what would be 12? PV would have to be 4. Okay, so example 2, we have the centroid in here again. G is the centroid. So you can see that because these markings are telling us that these are the midpoints on each of them, and they're connecting up to the vertices. So CG right here is 4. It wants us to find GE. So on here, if this is 4, and that is 2/3 of the way across, this is 1/3 of the way across. So the way I think about it is 1/3 is half of 2/3. So this piece is going to be half of what that piece is. So if this is 4, GE would have to be 2. And if you want to check that, you could say the whole thing is 6. So is 4 2/3 of 6? Yes. Is 2 1/3 of 6? Yes. Alright, so in example 3, it says we have an artist designing a sculpture that balances a triangle on the top of a pole. And the artist designed the coordinate plane. She designs it on the coordinate plane. The vertices are located at 1, 4, 3, 0, and 3, 8. What are the coordinates of the point where the artist should place the pole under the triangle so it will balance? So this is actually a fact about centroids. A centroid is the balancing point of a triangle. So that means if I have a triangle cut out of something and I want to try to balance it on my pen or pencil, then that's going to be that spot on there that it balances. So let's sketch out what we have here first. So they're all, I look at this and say all these coordinates are positive, so I'm only going to draw the first quadrant on there. So 1, 4, 3, 0, and 3, 8. Alright, so this is what I have going on. So if I need to find this centroid, I need to draw in a median. So the median has to go through the midpoint of one side and also through one of the opposite angles or vertices. So on here I look at this and I see that this would be easy to find the midpoint of and then connect it through to here. So since this is 0 up to 8, the midpoint is going to be at 4 here. So that's my midpoint. So if I connect this, now I have a median from the midpoint to the opposite vertice. And if I'm going to find the centroid is going to be somewhere in here. It's going to be cut into that 2/3, 1/3 ratio. So this distance along here, this distance is a distance of 2. So this has a length of 2. So I need to know this is going to be 2/3 of the way across that. So 2/3 of 2 is 4/3. So this point, which is my centroid, is going to be 4/3 to the right of this point. So it's 4/3 to the right of 1/4. So that would mean the x coordinate on here is going to be 1 plus 4/3 to move it to the right. So if I want to add these, I'm going to make this into thirds. 1 as thirds is 3/3. So this is my x coordinate now, and the y coordinate doesn't have to change at all because it's on that line. So 7/3, 4 would be the exact point of where that centroid would be. And that would be the balancing point for this artist to make this design. Alright, so you have 2 to answer on here. And for your joke, what do you call a pig that does karate? It's pork chop. Alright, have a great rest of your day and make sure you're kind to someone today.